So when we left off yesterday talking about normal distributions, we had talked a little bit about this. We'd gotten an idea for A just based on setting up our graphs. But what we had not talked about was finding the actual z-scores. And so I want to review just a little bit, and I'll kind of catch up those that weren't here, at least somewhat. But we are starting to talk about z-scores, which we have a formula to find z-scores. The data value minus the mean divided by the standard deviation. And the idea here is that allows us to compare, for example, here, trying to compare an SAT score and an ACT score. Trying to compare two different things by looking at their means and standard deviations. Okay, so we had, what was it? Ella and Alicia comparing scores. We had Ella's SAT scores, 1380. Alicia's ACT score is 32. Now, work with me. Let's set these graphs back up like we had them yesterday. Mean SAT is 1,000, standard deviation of 200. Remember, where's the mean on these normal distributions? Mean is in the middle. It's at top of the curve, right? And so this mean in this case is 1,000. Each line represents a what? That's the vocabulary there.
I don't know.
Each line represents a, those you that were here, standard deviation, yes? And so if I have a mean of 100 and a standard deviation of 200, one standard deviation above is going to put me at 1,200? You guys have these numbers on your paper too. Help me out here. This is one standard deviation above. What's two standard deviations above going to put me at?
1,400.
1,400. Add another 200. That's two standard deviations above. And three standard deviations above? 1,600. Going the other way. Remember, you're subtracting standard deviations. So one standard deviation below is going to put me at?
800.
800. Two standard deviations below? 600. And three standard deviations below? 400. So each time we're subtracting a standard deviation.
Why do you write minus the zeros?
Okay.
20 and 30.
Those are, remember sigma? So we talked about sigma last week, and it appears yesterday, but that sigma stands for standard deviation. And so those are the sigma signs. Okay, I just used to do those last week, and they're also in the beginning of the notes yesterday.
But then why are the next ones 20 and 30?
It's positive. As we move to the right, we're going positive.
Oh, it's
so this is
sigma. Okay, my fault.
1 sigma, 2 sigma, 3 sigma.
Okay.
And this is going to be -1 sigma, -2 sigma, -3 sigma.
That's what happens when you miss 4 days out.
Now, with this in mind, where was Ella's score?
1380.
Ella has an SAT score of 1380, which ends up being where?
Right below 2.
Yeah. Ella's score of 1380 ends up being right before 2 standard deviations, right? So it's just a little bit less than 2 standard deviations from the mean. Now, let's do the same thing over here for Alicia. Okay. And I guess I should have, this is our SAT, right? So over here, this is our ACT. What is the mean?
21.
Mean is 21. And what is our standard deviation here? Standard deviation of 5. So when we go one standard deviation to the right, and I don't know if this will, if I go plus 1 standard deviation to the right, that puts me at what? 26. If I then go a second standard deviation to the right, that puts me at 31. And if I go a third standard deviation to the right, that puts me at 36. Okay? If I go left, If I go left, so -1 standard deviation, if I go left 1 standard deviation, that's at 21 minus 5 is 16. Left 2 standard deviations is going to be at 11. Subtract 5 again, and minus 3 standard deviation puts me at 6.
That's right. 6, 11, 16.
Where does Alicia's ACT score fall?
Right after 2 deviations, so it's like right after 31. And
Okay.
it's 32.
Her score is a, what do we say, 32? And that is right past 2 standard deviations. Okay? So based on this information, just based on setting up the chart, filling in the graph, what do we know? Who scored better?
Alicia.
Alicia scored just a little bit better because she was about 2 standard deviations or more above the mean, whereas Ella was almost 2 standard deviations, but not quite. Now, the idea here is that we can compare z-scores, and that's what we're introducing. So when we talk about z-scores, and this will confirm it, I just want to show you the connection here, data value minus mean over standard deviation. So if we look at Ella's, okay, Ella's z-score, data value, that means the number in question. Okay, what was Ella's score? Ella's score was
1380.
1380 minus the mean. What is the mean for her?
1000.
1000 divided by standard deviation, which hers was
200.
200. What is 1380 minus 100 divided, and then hit equals and divide by 200?
Don't try to write it. We got
What are we getting?
1.9. Make sure that's right.
Does 1.9 make sense?
Yeah, because
Because-
it's right below
Yeah.
2.
We know that it's supposed to be right below 2 standard deviations, and so 1.9 would be right below 2 standard deviations. Now, let's check Alicia's and see if it makes sense in the same way. So Alicia's z-score, what's her data value? 32
Minus 21.
minus the mean, which was 21, divided by the standard deviation, which is
2.2.
5. 32 minus 21, and then divide by 5 gives me
2.2.
2.2.
2.2.
It's 2.2 an answer you would expect.
Yeah.
Yeah, it shows me that's just slightly more than 2 standard deviations above the mean. So, we already talked about this. We already agreed who has the better score,
Alicia.
and that was Alicia. And you can argue this either way. You can be general because we have the data to support it that her standard her score is more than 2 standard deviations above the mean, compared to Ella's, which is less than 2 standard deviations above the mean. Or you can compare z-scores. Alicia has a higher z-score of 2.2. Okay? So I'm going to say her score is more than 2 standard deviations above the mean. Okay. And if you want, you can say z-score is 2.2. Okay. And I guess if I had more room, I really should say, as opposed to Ella's, which was 1.9. There. Okay. That's the way we can use z-scores, and that's what we're going to be using the z-scores for, is to be able to compare. Okay. Get what we need for A, and then look at B. How does an SAT score of 1120 compare to an ACT score of 23? What are we going to do?
1120 minus 1,000.
Okay. 1120 minus 1,000 divided by 200, what's he doing? He's finding the z-score, yes? So as he finds that z-score, we're going to be able to compare here. Oops. So for SAT, 1120 minus 1,000 divided by 200. It's a data value question minus the mean divided by the standard deviation. And what do we get? What is it? 0.6. So the z-score is 0.6 for the SAT. And now what?
The ACT.
Repeat the process on the ACT. Data value minus mean divided by standard deviation. The data value we're using is 23 minus the mean of 21 divided by a standard deviation of 5. 23 minus 21 divided by 5 is 0.4. Okay. How does an SAT score of 1120 compare with an ACT score of 23? Which one's the better score? The SAT score is the better score because it is 0.6 of a standard deviation above the mean, whereas the ACT score is only 0.4. So the SAT has a higher z-score, and thus is better. I really should have said the SAT score. That's what that really should say. The SAT score has a higher z-score and thus is better. Something to explain to be able to understand as you look back at that. And I know, I squeezed those problems in at the bottom and I really didn't leave enough room. I really probably should have left more room there, but maybe that's just me. Okay, here you need on that, and then we'll look at the back page there. As we go into the back page, we start talking about using a z-score to compute percentage. Okay. When we talk about standard deviations, that gives us some information, but we also want to be able to compute that or convert that to percentages, which is what we're going to do here. We have what we need here? I think we do. So, and this goes along with what we were just doing. When you calculate the z-score for a data level, you're finding its corresponding value on the standard normal distribution. The standard normal distribution is the normal distribution with a mean of 0 and a standard deviation of 1. So what we were just talking about here, so that middle, as always, represents the mean, right? If you have a z-score of 1, you're 1 standard deviation above the mean. 2, you're 2 standard deviations above the mean, so on and so forth. So this is your standard normal distribution. Now, we also talked about this yesterday. The total area under the curve of the standard normal distribution is equal to 1, and represents 100% of the data values. So underneath your curve is 100% of the data. Okay? Spread out like we talked about yesterday with that 68, 95, and 99.7 percentages. Okay. The percentage of values less than or equal to a particular value is equal to the percentage of the total area under the distribution curve for that population to the left of the data value. This percentage is called the percentile of the data value. The percentage area, and you want to pay attention to the fact that it says to the left of a data value, is equal to the area to the left of the value z-score under the standard normal distribution. For instance, from the mean to the left of the mean is going to be 50% of the data, right? So we're going to be able to change this to percentages. Obviously, the mean is the easy one. The others are the little bit more challenging ones. And then what I'm going to take you through to calculate the area under the curve of the standard normal distribution to the left of the z-score, use a spreadsheet program such as Excel or a calculator. I have not gotten around to figuring out if the scientific calculators do this or not. I would think they possibly do, but I've not gotten around to figuring it out. So again, I'm going to teach Excel because that is what we can all use, and then we'll go from there. Okay? So this is going to be the idea, no matter what the z-score is, you can convert that to the percentage, okay, or the percentile. So let's talk about some gorillas. The weight of captive adult female lowland gorillas is normally distributed with a mean of 82.3 kilograms and a standard deviation of 15.33 kilograms. We're going to start off, and I broke this into pieces. Calculate a z-score of Sasha, whose weight is 61.8 kilograms. Okay? How do we find Sasha's z-score?
Actually, I think Sasha's actually underweight. Oh, wow. Caroline, good job. Don't you gotta do the 82.30 minus 61.8 divided by 1533?
Okay, except reverse it. We want to start with the data, the provided data value. What is our data value here?
15.33. Oh, it's the standard deviations. Yeah.
Sasha's weight of 61.8 minus the mean of
Oh, well, that's me getting this.
82.3
Yeah.
divided by the standard deviation of 15.33. Okay, so yes, Sasha's below weight.
Good job, Sasha.
Hard to think about because we don't compute kilograms, do we? Our brains work in pounds. At least my brain works in pounds. So
You get, negative 1.3372472228.
yes, big long number like that.
That's about right.
Okay, I have written down that when you subtract on top, it's negative 20.5, and then you're dividing by 15.33, which is that negative 1.3372472228 is what my calculator gave.
Should we write all that, or
You can if you want, but I'm going to go 2 decimal places.
so negative 1.3?
Okay. So I'm going to use a z-score of negative 1.34. Now, the question then is how can you use this score to find the percentage of captive adult female lowland gorillas whose weights are less than or equal to Sasha's? So we want to know the weights that are less than or equal to Sasha's. Now, keep in mind, this negative 1.34, that's saying that her weight is 1.34 standard deviations less than the mean, right? Because it's negative. Okay. To change that to a percentile, this is where we're going to pull out Excel.
All right.
now. 50-50 shot. Is mine going to...
Do we need the chart thing?
You need Excel again.
Yeah.
I almost wonder if I even need to demonstrate on the video, but... Let me see if I can screen mirror real quick. Okay, what is it? Okay. Now, I'm already in Excel. I already have a new worksheet. Yes, actually, I'm on the worksheet I used last time because that is... There we go.
We're doing the standard thing.
Okay, so we're doing a different one now. So you go into the same menu you've been in the past, which so mine is under the 3 dots up here. Now, I did discover some people, actually I was on my other iPad doing this at home, and if you don't have the 3 dots and you have more menus across, wait, what was it? It's not the right, it was some zigzag symbol. No, I keep wanting to do a square root. Oh my goodness.
Oh, I got you right here. Here. Nope. Okay, she's got it. All right.
A symbol like that is what you might find at the top of your menu screen.
Nope.
That's-
It's like
Okay.
a heartbeat.
Like, in other words, if you have that symbol in one of these, that's your statistics. So, going into statistical. Oh, I just saw it right there. It's that symbol right there. That's what means it's statistical. Okay. Anyways, you are going down to normal. And we're going to use the one that is normal S dist. So normal standard distribution. That one right there.
Yep.
And when you get there, normal S dist, it asks for Z, as in the Z score. And then it asks for a cumulative, which cumulative is always going to be 1. Okay? So in my Z score, I'm going to type the negative 1.34. And then cumulative, you put 1.
That's it.
Okay. Have you sign in?
I got it.
Maybe get out of there and go back
What do you
in?
put in the community?
Does that make sense?
1.
0.0901.
0.09.
I was 11 point.
What is going on here?
Okay, how about, okay, go back out of here.
So you guys see
That
it?
Excel right there.
Yep.
Okay. So,
Yeah, what homework are you doing?
Just delete it.
I guess it's, now,
Literally,
do
dude.
the sign in part. Right there.
Put that forward, but it's gone.
Wait, show your sign.
No.
There you go. There, okay, we're making progress now. That was great. Okay, did you guys get something? Negative 1.34. And my cumulative is 1. And from what I can tell, cumulative is always 1 that's representing the 100%.
Will we get a wrong answer since it's not the full decimal?
You would get a slightly different answer. Now, I think I tried this in Sophos, and I think they were using the rounded version, if that makes sense. You might have to play around Sophos a little bit, but I feel like if I used the full long decimal, I got the wrong answer in Sophos, if I recall. So I used the rounded version and was able to get the correct answer. Okay? Now, that 0.09012, That is what we're looking for.
Is that the answer to?
Right.
Well, okay, so that is your percent, but in a decimal form.
So it's 0 or no? It's not. It's 9%.
It's 9%, right? Or 9.012%, because to change a decimal to a percent form, we move the decimal 2 places to the right. Yes?
Yes.
So, okay, did everyone get that to work on their iPad?
No.
What?
I got 0.90943.
They need to go.
Did you? I think what you would.
I did it without the full number.
Not as.
9.012. But yeah,
Did you put the negative in? Well, that's weird that it should be throwing off more than that.
And then Z, the number negative 1.34. And then accumulative is 1.
Yeah. Negative 20. Yeah. Negative 1.34.
There you go.
No, why? Oh, that was 9.9, wasn't it? So 9%.
Yeah.
Okay, that makes more sense. Okay, so negative does matter. FYI, negative does matter.
Yeah.
Yep.
Okay, let me go back to my slides. Everyone else got to work, yes?
See.
Now, I'm going to write down some information here. So, first of all, I used Excel. I was in the Formulas tab, right? I went to the Statistics menu, which Statistics menu. Why can I not draw that silly symbol?
It's like a heartbeat thing. Yeah.
It is, but I can't draw it for whatever reason. And then once I was in there, I went to norm.s.dist, as in standard distribution. Now, when you look at this, you need to realize, and this is going to be important as we continue, that this calculates area to the left of the z-score. Okay, calculates area to left of the z-score. Got it?
Yep.
So for the problem we just did, we pulled up norm.s.dist. You had to enter the z-score of negative 1.34, and cumulative is 1, so just 100%. We got 0.09012 as the decimal form of our percentage.
Which is
When we change that to a percentage,
9.012.
and I just have mine, I just did a tenth, so 9.0%.
So what if I just left it like 9?
9% would be okay here. Only reason I put the 9.0 is because as I go through the rest of this page, I do have one decimal place. Okay?
Why is the cumulative represented?
My understanding is it represents 100%, like my cumulative is I want 100% of the data.
So is it always 1?
Yes. Yes. I'll be honest, I was a little confused on it at first too, so I had to kind of figure that out. Okay, let's try these other ones, okay? You will have several in homework. They're just find the percentage of all values in a normal distribution. And this one is with a z-score, with z greater than or equal to 0.62. Okay, so what are we going to do here? We're going to go into Excel. Normal s.dist. What are you putting in? What's my z-score that we're putting in?
Is it still the negative 1.34 or no?
Now I'm on a new problem.
0.6.
If I'm looking for z greater than or equal to 0.62, we're using the z-score of 0.62,
Yep.
cumulative of 1 for 100%.
And this is it? That's it?
Well, not exactly.
73.23%.
Okay, so the spreadsheet gives me, what is it? Point,
7.
0.73237. What is that as a percent?
73.
73 point, give me one decimal place,
2.
2%. Now, you enter that in Savas, you're going to get this wrong.
Why?
Greater than or equal to.
Not exactly.
Oh, you're close to it. I was thinking.
This is where we need to go back and look at this statement right here. What does this function do? It calculates the area to the left of the z-score. So, this is saying that 73.2% is to the left. What is this question asking me?
All right.
Because it's greater than, it wants to know how much is to the right. Now, I don't have a different way to do this in Excel. So what am I going to do? Subtract my answer that I just got from 100. Okay, because this right here is to the left. We want to the right. And so now I'm going to go 100 minus 73.2%, which is 26.8%.
And that's right.
And that's your answer. I boxed it. I made it official. So that is the one thing. I'll be honest. I got caught on this in Savas the first time I went through it too, because the book examples only give us problems to the left. I didn't have any where I had to go to the right. So I made sure that the notes instead had stuff. So beware. If they're asking for less than, your normal distribution function in Excel will give you less than. Okay, it's going to give you everything to the left. If it's asking for greater than, you're going to have to subtract from 100% because they're giving you the left, subtract from 100 to get the right values. Understood?
So the less than, that first answer would be our answer.
Yes, correct. Okay, two more to practice with real quick. Find the percentage of all values in a normal distribution with z less than or equal to 1.85. What are we doing? In Excel, norm.s.distribution, what am I putting in there? Z-score of 1.85, comma, 1. What does Excel give me? What do we get? 0.96784. Okay. What was this question asking? Well, actually, we can change this to a percent regardless. What is this as a percent? 96.8%.
Boom.
Am I done or am I not done?
You're done.
Because this problem was asking about less than. When it's asking about less than, it's asking for all the area to the left. This function finds area to the left. So the 96.8% is all the area to the left. And think about it, guys. This is a positive z-score, yes? Almost a z-score of 2. Does it make sense that there'd be 96.8% to the left of it?
Yeah.
And it should. Okay. Up here, we're looking for to the right of 0.62. Well, again, there should be less than 50% up there. One more. I'm assuming we have the idea now. They gave me a z-score of 0.48. Fill that in, and what is Excel telling us? 0 point
0.68439.
68439. What is that as a percent? $68.4%.
You're gonna do 100 minus that for your pound.
Why am I doing 100 minus that?
That's what you did on your page.
Okay, this example is asking me for greater than. When it's asking me for greater than, I want to know the area to the right. And in order to get the area to the right, we're always going to do 100 minus the other number. So 100 minus the left. So 100 minus 68.4 puts me at is it 31.6? Okay, so beware. Pay attention to left versus right. This form finds what's under the left. If you need the right, subtract from 100. It's a lesson 11.4 in Savas. Okay? And you have a few minutes you can be working on it.